Hi, welcome to the video tutorial for a lesson called Chocolate Box. It's in the function strand and it introduces children, it allows pupils to compare linear and quadratic functions and actually their meaning in real life. One thing to say about the Thinking Maths lessons is they will come to a point in the lesson where your pupils are used to these routines and used to the way that we want them to work mathematically, that you kind of lose control of the lesson, not in a very negative way, but the children will start to express themselves mathematically. They'll have mathematics agency, so they'll act as mathematic beings. And I think that's interesting. So you become, all these words kind of don't do what happens in the lessons justice, which is why as part of this project there is a lot of classroom support. Whereas the pupils will just start being mathematical. They'll start solving problems and you will just do maths with them. These are very, very rich tasks. There are levels to them, which is good because you can always go higher, and that often fits with the way people thinks. But this is a key point where there are several ways you could manage this lesson. There's a time when you can go to develop equations and formula. There's time where you might just want to go and express it graphically. And I've done both, and I know either way is equally fruitful. And sometimes you could spend quite a long time on this lesson. I know some schools might have over an hour lesson. You could really do this lesson justice in an hour. So the image we use at the start is of two children sharing chocolates. And I'd often pick children from the class and talk about what a child who's got a sibling who's greedy and tries to trick them with a box of chocolate, and that the greedy child likes the white chocolates and the other one likes the dark chocolate in the middle, and you're wondering why they're so upset. And you say to the children, well, why? Oh, well, he's upset because he only gets 1 and she gets 8. So that's why he's unhappy. And you say, okay, what she doesn't realise is there are layers to this chocolate. And so the pupils now do a period of drawing. And again, like several of the lessons, often it's how they draw their ideas can be linked to the maths. So the algebra that they develop is linked to some logic that's present in the picture. So you would say, well, how big was the chocolate box before? 1, 2, 3, 4. There was 4 on the side. Oh, no, there wasn't. There was 3 on the side. You think, oh, so when there was 3 on the side, the outside of the border was 8, and the inside was 1. Do you think that's always going to be the case? Let's look at 4. Because a lot of pupils will think the outside always gets more chocolate. Let's look at 4. So remember, the side number is 4. So when the side is 4, the border is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the inside is 4. 1, 2, 3, 4. And that's what you give them. So you give them a big sheet of dotted paper and they draw layers of chocolates. And what they do is they keep a note of the side number, and they keep a note of the border, and they keep a number of the inside. So you just give them a number. As I say, a lot of them think that the outside will always get more because it's all the way round and it's bigger. Obviously links to to the idea of area and perimeter as well. So you let them do this and draw different boxes and struggle to write the numbers down. And until someone says, he's happy now. If there's 7 on the side, the inside's more. And then you move to a period after the drawing. Because I think the drawing is quite key here. Because what they suddenly realise is, when they draw, is how important the corners are. So to work out how many they get, you've got to take off the corner. So on the side's 4, the total number is 4 times 4 take away 4, because you take away the corners. So that's leading to how they express the algebra. So what they suddenly start to realise now is we can plot this in a table. And I would often get the pupils to come up and fill this in. So when it was 3, how many did they get when it was 3? It was 4. Have a check. When it was 3, oh, it was 8 and 1. Right? When it was 4, it was 12 and 4. When it was 5, it was 16 and 9. When it was 6, it was 20 and 16. And what I would encourage the pupils to do as they're writing their results in is to start looking for patterns and to start expressing patterns. And obviously, this is the key one because they just say, well, you had 4. Right? You had 4. This one is much harder to articulate because you're going up by an increasing amount every time. And so there's a lovely period where they try to articulate what's happening to this pattern. And some of them will say things like, you're adding 4 here, and some will say, you're adding 2 here. They don't say you're adding 2 more each time, but they'll say you're adding 2. And I'm saying, really? 1, 3, 5? And they'll say, no, it's 3 there, you're adding 3 there, you're adding 5 there, you're adding 2 more to what you're adding. And so you're moving to a situation where they find this very hard to articulate. So you've got to give them time and space, and it's very humorous when they start to articulate this. So the key bit is you could do the total dots as well, because some people spot the pattern of there's 9 here and there's 16 here, and they could do it that way. But it's these 2 patterns, increasing patterns that are increasing differently, that you want the children to struggle to articulate. So there are now 2 options in the lesson. You could go straight for plotting the graph. I think for many pupils, and I'm not going to do it accurately, for many pupils, this suddenly gets them to realise it's more than when we did the gardens lesson, which is why it was mx plus c, the slope and the intercept. They get a sense of the graphs are meaning something. So they've got a sense of someone getting more chocolates. They've actually seen them from drawing it. They've seen the pattern increasing. They can see this inside getting much bigger. They've got the numbers. This one's going up in 4s. This one's going. So that really makes sense to them. And when you plot the graph, you end up with a scenario where you have that. And there's hundreds of things they can say about this graph, but it's this idea of seeing the patterns of growth and what it means. And what does this mean? And if this is the inside, and this is the border, this is the white, and this is the milk chocolate, this was the happy girl, right? So there's meaning in these numbers. We're relating it to meaning, so it's real to them. It's not some abstraction on a board. It means something. People have even done it with chocolate, with their boxes of chocolates where they've added things in. But the sense of, hang on, he's happy now, and she's not very happy. Oh, so what's different about these? And then suddenly they'll see that add 4 here, and then the add 7, add 9, add 11. So this increase is going up each time. And I think it's lovely for them to be able to make meaning of this graph. So in some schools, and sometimes I've gone straight for that. In others, it's this lovely exploration where you can say, how can I get from the side to the border? How can I get from the side to the dot? So you've got 3 to 8 to 1, 4 to 12 to 4. So how can I get from there to there? It's a bit like the ratio lesson on the slides. And some pupils will quickly realise the idea about the side numbers that you've got to take away 4. So they'll say, oh, you just times by 4 and take away 4. And how they express that is a very rich. So they can say, the border dots is equal to the side 4s minus 4. There's hundreds of ways they can express that. And how they do it is very, very rich. I think for some groups it's worth dwelling upon that. But what about that one? How do we work that one out? that's interesting. There must be a way of doing it. There must be a way of working the inside out from the side. Let's have a look. And I think sometimes it's so when there's 5, there's 16 and 9. So I think it's worth giving them that to struggle with. They know it's possible. They know we can express patterns algebraically. They've done that in the half-time score lesson. You know, add 1 to each one and multiply together. What about this one? What? And they start looking for different ways of doing it. So what if we take away 2 and square it? Does that work? 5 take away 2 is 3. 3 threes are 3. 4 take away 2 is 2. 2 times 2 is 4. And so you've got side take away 2 squared. Lovely opportunities for getting children to express patterns graphically. They're all kind of rolling together. So we've got the idea of the scenario of the chocolate box. The children will draw. They'll see patterns in the way they're drawing. Then you can look at the number patterns and name the number patterns and describe the number patterns and look at those graphically and see that one is going up in a straight line, linear, the other is curved, quadratic. But then you've got the expression of the ideas algebraically. Very, very rich lesson. I don't think explaining it really does it justice. It's lovely to see your children engage in this activity, a very rich one, and construct the maths in front of them. So they're being mathematical. They're using their skills to explore different scenarios. And all your job is to kind of guide them, is to give them the right input, to steer them at the right time so they don't go off course, but then just let them do their own thinking, let them do their own explaining, let them argue and talk to each other. A lot of people have told me in these lessons they know it's working when the children say, "Oh, go away, miss, go away." Say, "We're working on this. We'll tell you when we're ready." And it's just lovely to be able to say to the children, right, share your ideas with the rest of the group and let them have a debate about which ideas they really like. Can they spot any flaws in someone's arguments? Can they develop it? Can they improve it? Which has helped them? Who's seen ideas that are different to yours? A very, very rich, profitable period of mathematical thinking.